Let's start with a practice problem using the equation and the information we've already learned. What amount of energy is released by 900 grams of water as its temperature changes from 66.0 degrees Celsius to 11.0 degrees Celsius? Well, looking at this problem, we see 900 grams of water releases energy to the surroundings, causing the temperature of the water to drop. We start by restating the kinetic energy expression, Q equals mc delta T. We're looking for the amount of energy, Q. I can expand delta T to show that it's derived by the difference between the final temperature and the initial temperature. Since the temperature is dropping, we shall expect the loss of energy to yield a negative answer. Adding in the values, you must make sure that the units of the specific heat capacity found in your data book include the same mass unit as the given mass in the question, that is 900 grams and 4.19 joules per gram degree Celsius. The answer has far too many significant digits. It should be expressed to the least number of significant digits found in the question, in this case 3. So either express your answer in scientific notation or, as I've done here, change the unit of energy accordingly. You must read the small print in exam questions to make sure your answer is presented the way you are told to express it. Here's another problem. The combustion of natural gas on a stovetop releases heat to change the temperature of 500 grams of hot chocolate as shown below. What is the specific heat capacity of the hot chocolate if the energy involved is 102 kilojoules? The energy released by the combustion of the natural gas increases the temperature of the surroundings. Some of the energy heats up the air surrounding the stove, some heats up the pan itself, and some heats up the hot chocolate. We're only considering the energy is used to change the temperature of the hot chocolate by 50 degrees Celsius. Again, re-express the kinetic energy equation, and before you start adding in values, algebraically manipulate the expression so that it is in terms of what you're looking for. Add in the values from the question. Notice I've converted the mass from grams to kilograms. I could just have easily converted the energy term from kilojoules to joules. Either way, the answer will be the same. And present the answer to the indicated number of significant digits. It is important to see that the magnitude of the answer is exactly the same in kilojoules per kilogram degrees Celsius than it would be in joules per gram degrees Celsius. Energy changes in chemical reactions. Chemical potential energy exists in the bonds between atoms of compounds. For example, glucose is a naturally occurring molecule that has a large amount of chemical potential energy between the atoms. By enzymatically breaking up the glucose molecule, energy is released as the atoms form molecules with bonds of lower chemical potential energy. Energy released from the reaction increases the temperature of the surroundings. A reaction that needs to absorb energy from the surroundings produces products that have a higher potential energy in the bonds between the atoms. This is the cellular respiration reaction. In cellular respiration, the biological combustion of glucose, a high-energy molecule, forms carbon dioxide gas and liquid water, a low-energy molecules, and releases energy to the surroundings. In most biological systems, the energy is used in the phosphorylation reaction of adenosine diphosphate to form ATP, the energy currency of cells. High-energy products such as ATP require energy in order for them to form. Most reactions that produce products that have a lower chemical potential energy than the reactants are spontaneous. Lower energy products are always favored. When energy is released to the surroundings, the reaction is exothermic. ATP was an example of a high-energy product formed from low-energy reactants. In this reaction, this is photosynthesis. Glucose is also a high-energy molecule, and it is also synthesized from low-energy reactants and an input of energy. This energy came from the sun in a process we know as photosynthesis. The sun is responsible for providing the chemical potential energy in the bonds of all naturally occurring hydrocarbons, including those found in fossil fuels, and the carbohydrates we consume. The term given to the reaction that absorbs energy from the surroundings is endothermic.